Okay, welcome back. And this is going to be a pretty short video. And before we begin, I'm going to show you how a typical honeypot setup looks like. So, for example, this is like a diagram of a corporate kind of network. We have both the corporate LAN, we have the server farm, the DMZ, as well as the first and second tier firewalls. Okay, so as a rule of thumb, most experts actually recommend having like maybe 20% of your honeypots on each different segment. So you assign like 20% of the IP address for each segment to honeypots. Okay. In real life, obviously, you can adjust that number because not every organization or company will have that many IP addresses to spare for that many honeypots as well. Okay. Yeah, so this is just like a kind of like a rough gauge for it. But typically, what they do is that they deploy out maybe 10 or 20% of the IP addresses as honeypots on each segment. Well, the reason for this is that's exactly how honeypots work, by the way. So when there is a malicious threat actor or user within the network itself, no, or that's I mean usually these are like machines which are compromised already, right? Via phishing attacks and things like that. So once they are compromised, they become an infected node, and the infected nodes can actually start to scan the same network, its own corporate LAN or DMZ or server farms for any kind of like machines which can be actually attacked. In this case, when they scan the honeypot, they will see the honeypot as a legit target that can be taken out, and they will try attempt to attack the target. So they can even kind of like move laterally through your networks as well. So for example, like the infected nodes, they could actually scan laterally and then try to attack vulnerable machines within your server farms, with your corporate LAN, and vice versa. Okay, so that's basically how honeypots worked on a high level. So just a little bit of background. Cowrie Honeypot is basically an open source honeypot that you can actually download and install. I won't be going through the installation steps. All this information can be found online. You can use ChatGPT to teach you how to set it up. I'm just going to show you on a very, or rather, I'm just going to show you very briefly how this honeypot actually works. And it's a very interesting thing actually. Honeypots are not new, by the way. They're quite old. Okay, they've been around for like probably like at least maybe 2 decades or more. So Cowrie is basically an SSH honeypot. So it works like a SSH daemon. It is kind of like it has both SSH as well as Telnet, so it can be configured to listen on both port 22 and port 23. Okay. Uh, yeah, so I'm going to dive right into the Cowrie workflow. The Cowrie workflow looks something like this. Now, this can change because I realized that no, I configured Cowrie to look at the Cowrie log, but we can actually look at the Cowrie JSON files, which have a lot more information that we can extract from the log. Okay, but basically there's like four components to this setup. So there's Cowrie itself, which is the honeypot service. There's Promptail as well. Promptail is basically a service to watch log files like .log or JSON files. And there's Loki. Loki is running on port 3100, and Loki is basically used to receive and store those logs. Okay, so Promptail looks for Promptail actually watches the actual logs itself, and then what it does is that it attaches labels to those and pushes the logs to Loki. Okay, and Loki will store the logs, and Loki exposes those logs via API for Grafana to query. And Grafana connects to Loki as a data source. Okay, so Grafana you can actually add Loki as a data source, and once you add it as a data source, you can create a new dashboard. You can create queries within the dashboards, okay, to display whatever information you want. Okay, that's basically how it works. So without further ado, I'll just go straight and show you and demonstrate to you how it works. Um, I'm going to pause the video for a while because I need to start up my virtual machine. Okay, and we are back. So right now I'm on the Cowrie Honeypot machine that is running, and I'm going to open up a browser on the machine. Now, do take note that in actual deployments, there will not be any graphical kind of desktop on those honeypots. So I installed I'm using a graphical a VM, an Ubuntu VM with a desktop, is because I want to be able to access it quickly and demonstrate points quickly. Okay, so in real life, no people just deploy it in command mode, command line, so there won't be like graphical for you to interact with. The graphical comes from the web, the web UI of the of Grafana. So Grafana is where you see all these information. So right now I'm on the dashboard that I have created called Cowrie Honeypot. Now let me just show you a little bit on how does this actually work. So before we go into it, okay, the data sources from Cowrie, okay, this has been already configured. So it is going to uh, it basically is going to get it from the Loki is on 3100, right? So port 3100. Yeah, so this is actually added as a data source, and once you have it as a data source, you can actually create a new dashboard, and within the dashboard itself, you can edit and you can actually add you can add visualization and stuff like that. Okay, so each of these will actually show up as a panel. So these are all panels. So I have a set of pre-configured panels which are going to display different sets of information which are actually pulled from the log files. Okay. However, right now, because I just restarted the honeypot, so you can see that most of the panels are actually blank and there's nothing inside. But I'm just going to show you a quick demo of how do we trigger the honeypot. So again, like I said earlier, Cowrie is a SSH and Telnet honeypot, and in this demo, I'm going to simulate the SSH connection to it. Okay, so once the attacker gets onto the network, he starts scanning and he realizes that, oh, you actually have a couple of IPs which are listening on port 22, and he'll probably try to run brute force attacks, like Hydra and stuff like that. He's going to try brute force attacks against those SSH services that he sees. So I'm going to simulate the connection. I have over here a mobile extern. Mobile extern, I've configured one of the connections already to Cowrie. And when I double click, I'm going to log in as, let's say I'm going to log in as just admin or something. Okay, it can be anything. And again, I've set it to not have a password. You can set it to have password, so you can actually kind of like listen in and look for brute force attempts against the machine. But I set it to have no password, so I can just go straight into the honeypot. And basically, they can even interact with the honeypot. It looks like a real server. In fact, if you do like uname, uname command, you look at it and you feel like, oh, this is like a Debian server, but it's not. This is running off an Ubuntu server. See, so yeah, there's kind of like a lot of stuff in. You can even, you can kind of like issue commands to see where you are. You can issue commands to list files and stuff like that. Okay. Now take note that whenever the attacker interacts with the SSH session this way, all his actions are being logged by Cowrie, okay, and and um, ingested and passed, and all this information is being sent up into Grafana and is being created as queries which are represented in panels on Grafana. Okay, so that's how we can look and study what's happening, what the attacker is doing actually in the background. And to simulate all that attacker activity, I have a bunch of trigger commands that I'm going to just use. Okay, you can just copy the trigger commands and we can just paste a whole bunch of it in. Okay, so obviously these commands are not real. They're just to simulate activity within the SSH session. And let's just go back to the Grafana, and the Grafana dashboard. You can see that that already shows me, like, top 10 source IP addresses. Um, there's already a new SSH connection over time. Okay, and you can actually see stuff like, these are like login attempts. Okay, Cowrie log stream. Command executions, you notice that they are already tagged with CMD, so it's saying that these are commands that the attacker have executed on the honeypot itself. Okay, yeah, and then we have things like outbound connections, because if you do something if you do something like a wget or something, those are considered like outbound connections. So it's able to see outbound connections, or maybe you may try to SSH into a different machine from there. That is also seen as an outbound connection. Okay, file download attempts, because I was trying to download a couple of files. Okay, even the iCar test virus file and a whole bunch of stuff, potential exploit tool usage because there's a malware.sh script. This script doesn't exist, by the way, but because I'm trying to so-called execute a script, so it looks as if something is happening. Yeah. Recon commands, okay, because I'm trying to cd, I'm trying to ls and la to list the files. I'm trying to show my path, my working home directory, my working path, pwd. Yeah, so all these tell me that yeah, somebody has actually been on the honeypot and somebody is doing something to the honeypot. So we know for sure that we do have an attacker. If we see any new activity coming in, we know that we do have an attacker. Yeah, so honeypots, generally speaking, they wouldn't log anything if let's say if they're properly configured, they wouldn't log anything unless there is real activity that's happening on your network. So honeypots are dispersed throughout the network, and basically you just sit there listening for an attacker to come in and do something. And once the attacker starts interacting with the service, that's where you know that oh yeah, I do have someone for real who's know, sitting right now on my network and interacting with it. Now again, this might not really be a human person. This whole thing could be, it could be just malware. It could be really, really well written malware that has that full interactive capability as well as the ability to spread laterally and things like that, you see, which I believe a lot of modern day malware actually have. So yeah, again, whatever you see with honeypot, may not be a real person, but might be an automated script, it may be automated malware, that's already programmed and coded to do all these things. Yeah, so that in a nutshell, that's basically how honeypots work. Okay, pretty simple. I hope you enjoy this session and see you again. Thank you.